Hello friends, welcome back. So here is a question I got from one of my student as a doubt. Let me read it out for you. Find line integral of magnetic field integral b bar dot dl bar over a given loop. So there they given an instruction also. Direction in which integration has to be performed is indicated by the arrows. So here you can see they've given 4 questions. In out of those 4, every loop is having an arrow on top of it along with the directions of currents. So by looking at the question itself, it is clearly evident that we have to apply Ampere's circuit law. So let me write about Ampere's circuit law's mathematical form. Okay, what it states: line integral of magnetic field over a closed loop is always equals to mu naught times the current threading through it. Means those currents which have been contained by the loops you need to write, whereas those currents which seems to be outside your Amperian loop, no need to consider. It is similar to that of your Gauss law, where in Gauss law also we do consider those charges which are enclosed by the Gaussian surface, whereas how bigger the charge is, if it is lying outside the Gaussian surface, we will never consider it to calculate the total flux. So let me come back to the question given here. Look at the first one. They given two currents I1 and I2. I1 is pointed out, whereas I2 is pointed into the plane of the page. You need to integrate, or you need to find the line integral of the magnetic field over the circular loop in counterclockwise direction. So let me apply my right hand thumb rule for I1. When I am applying right hand thumb rule for I1, I need to point my right hand thumb out of the plane of the page, so that my fingers that are curling around the thumb, if you observe, they do curl in the direction given in the loop itself, that is counterclockwise. So both are in the same direction, so my line integral BDL, because theta being 0, integral BDL is mu naught times of I1. There is no I2 because I2 is out of my Amperian loop. Come back to the second one solution. If you see, same. This time I1 is outside my Amperian loop, whereas I2 is within the Amperian loop. So integral BDL is mu naught I2. But let me check the directions now. I2 is pointed into the plane of the page, so that gives me a magnetic field which found to be in clockwise sense, but I need to integrate counterclockwise. So in order to integrate counterclockwise, I need to reverse the direction of current. If I reverse the direction of current I2, that is, if I point it out of the plane of the page, then the field produced by it will also be in counterclockwise sense, means that sense in which we need to integrate it. So for that sake, I am reversing the current, thereby I am putting a minus sign in front of my current. So in this case, it is integral BDL is minus mu naught I2. Now let's check the third one. Third one, you are having two loops here. One is carrying current out of the plane of the page, whereas the second loop's currents are pointed into the plane of the page. So if I again apply my right hand thumb rule, pointing my right thumb out of the plane of the page for the first loop, that is giving me a magnetic field which is in counterclockwise sense, whereas the second one, the current which is pointing in, is giving me a current in clockwise sense. So integral BDL, in both the cases, if you see, I need to integrate it against the direction in which they asked me to integrate it. So in both the cases, I have to reverse the currents. So mu naught minus I plus mu naught minus I, because both the currents I have reversed. So that turns out to be minus 2 mu naught I. Hope it is clear. Let's go for the last and the fourth question, that is the last question. So again, let me find the directions of magnetic fields produced by all the 4 currents in the 4 loops. First one, current is out of the plane of the page, so the magnetic field produced by it, I am representing that with the green colored arrows in counterclockwise sense. Again in the second one, again this is also carrying current in the same direction, counterclockwise, whereas the third one, current is pointed into the plane of the page, so it is clockwise, whereas the fourth one, current is out of the plane of the page, so the field due to this will be in counterclockwise sense. So to get the positive term on the left side, which all currents are in agreement with the direction given in the question, they will give me positive currents. Which all are against the direction, the magnetic fields that are not agreeing with the directions given in the question, in order to make them agree, I need to reverse the directions of current. So here I need to reverse the directions of current for 3 times, the second, third and the fourth loops, whereas in the first one there is no question of reversing it. So it is mu naught I for the first one, second one mu naught I, third one minus mu naught I, fourth one is also minus mu naught I. So if I simplify it, it turns out to be minus 2 mu naught I. Line integral of BDL or B bar dot DL bar is equals to minus 2 mu naught I. Hope you got it. Any other queries about this one, you can drop it in the comment section. Thank you.